Hi, everyone. It is so great to be here with you. Many thanks to Women in HVACR for allowing us the opportunity to co-present with them today. So I'm going to share my screen, and I'm also going to go off camera so that my stunning appearance doesn't distract from the presentation that we're giving. And the detail orientation actually comes from that background I have in meeting and event planning. So I do come by it honestly, but we're not here to talk about me. We're here to talk about AMCA International. So just briefly, I've been with them for 3 years. I work on education programs and whatever that entails. So webinars, online learning, platform programming, presentations like Erica mentioned at trade shows, etc. So to get into who AMCA is, we are a nonprofit manufacturer association. So unlike a lot of associations where the members are individual people, our members are the actual companies that manufacture the industrial and commercial size fans, louvers, dampers, etc., that are used for installation in warehouses, in hotels, hospitals, large office buildings, etc., just to give you a broad perspective. We are over 100 years old. They started in 1917 with 6 member companies, and now we are fully international with over 400. So briefly, our mission currently is to advance the knowledge of air systems and uphold the industry integrity on behalf of AMCA members worldwide. And the 3 tenets we currently push that through with is advocacy, product certification, and education. So this gives you a brief snapshot of where our members are primarily located. North America, up until about a year or a year and a half ago, was leading the push, but Asia has really exploded with members in the past, 12 to 24 months. The Middle East is growing robustly, and we have plans to expand even more largely in that area. Europe is coming along. They tend to want to play by themselves, but we still welcome them at any opportunity we get. And down the road, we do have plans to expand Latin America membership as well. But North America numbers do also incorporate Canada and a few people that we work with in Mexico as well. So this is a very brief perspective of the products that we are involved with in the industry. Everything from air curtains to fans for both commercial projects and fire smoke control. Lots of fans. We joke that it's fans, fans, and more fans at AMCA, but we don't want to forget about our friends who manufacture dampers and louvers, because those are very vital, as many of you know, in things like hurricane-prone regions, in fire and smoke safety, etc. So here's an idea of what AMCA International provides to its members and the industry as a whole. We do publish international standards. We work very closely with ASHRAE, ISO, ICC, NFPA, SMACNA, all the associations that have something to advocate and promote in the industry. We want to be a part of that as well. As I said, we do product testing, and we also do certification of products. And a lot of people are surprised to know that we do that. We have our main laboratory, testing lab, in Arlington Heights, Illinois, where people who have these fans, louvers, and dampers send their product to us. They tell us, my product does this, it meets this standard, it performs in this way, and we independently, as a third party, test that product again for verification. If it passes with all of those criteria being validated, that's great. You get a certified rating on that program. If it doesn't, we send it back and we say, thank you very much, but you need to fine tune your testing program or retest it to verify what those details ought to be. And that's a whole separate topic of certification. And we have a webinar recording on our website that you can view if you want to learn more about product certification. And then advocacy and industry relations. We're very involved with things going on with the Department of Energy, the National Institutes of Health, a lot of government regulations and bodies we work with on the state and local and federal level to be in the conversation with new regulations coming out, things going on in states like California, Oregon, Florida, etc. We have a team of people that's all they do is work on advocacy efforts for the industry as a whole. And then, of course, we have marketing and education, which is a round-the-clock, nonstop job, and we love it, which is why we're here today. Briefly about certification again, why do we specify certified products? Well, it increases the reliability of the product rating. It puts us on an apples to apples comparison level so that we can say, yes, what manufacturer A, B, or C says, AMCA has verified that that is true. That product will perform as stated. We do random check testing. And so that ensures that through time, those products do consistently maintain their reliability and their performance. And then whether it's a physical catalog or an online digital catalog, we make sure that all the details are up to date and accurate, and that onus is on the manufacturer. Here's a snapshot of our AMCA certified test labs. We do have here Arlington Heights, Illinois. We work with Intertech in New York. We work with Cediat in France, Thomas Bell Wright in Dubai. We have our own Amca Asia lab in Malaysia, and then we work with KTC in Korea, and they all do different types of testing depending. So, you know, Thomas Bell Wright in Dubai has a good specialization in sand louver testing. Not much of a need for that in Cortland, New York. So we have different ways of having different products tested internationally. For anyone who wants more information about AMCA, this is our website, amca.org. We have everything you could want to know about us: advocacy, education, certification. Our publications and standards are listed there, things about meetings, how to test products, etc. So it's really a robust website to look around. And I'm going to put in a shameless plug for our own online learning platform. You can connect to it through our website. Go to the Educate menu, go to Online Education Portal, and on that site, we have about 30 webinar recordings. I would say 99% of them are technical in nature. They do qualify for PDH credits. We offer various more robust modules about fan system effect, about the fan energy index, which I'm sure many of you have heard of. So please feel free to check that out. And we'll come back to this slide at the end of the presentation. But that's a brief overview of who AMCA is and what we do. And with that, I am going to attempt to stop sharing my screen so that we can bring Kristen on. So Kristen Neath works for Kinetic Noise Solutions in Canada. She's based in Canada, though they do have other offices. She and they have been a member of AMCA for quite some time, and I'm trying to stop sharing my screen. Here we go. So I do want to bring Kristen up. Kristen, if you want to go ahead and share your screen.
Okay, thank you, Lisa.
And if you could, because I don't have your bio right in front of me, please give some background information on yourself for the audience.
Yeah, will do. That's actually my next slide. So
Cool.
First of all, I wanted to thank you, Lisa, and Erica for inviting me today. My name is Kristen Neath. I'm the Canadian National Sales Manager for the Industrial, Commercial, and Environmental Markets at Kinetic Noise Control. A little bit about me. So you already know my title. I have a bachelor's of engineering in mechanical systems engineering, graduated in 2014. I started with kinetics noise control right after graduating. But before that, I spent a lot of the time while I was in school, either through co-ops or just working at a machine shop. So I got quite an extensive knowledge in sheet metal design and fabrication. Very little acoustics knowledge before I came to kinetics as well. Very limited, basically starting from nothing. But through the last 7.5 years that I've been with kinetics, I've gained quite an expertise in mechanical HVAC noise, design and application of products. And that's a little bit what we're going to talk about today. So kinetics noise control, just a little bit of a background about us. We were established in 1958. Our corporate office is in Dublin, Ohio, but we do have smaller facilities in California, in Ontario, Canada, and also in Hong Kong. And essentially, we are a manufacturer of noise and vibration control products. So what that means for us is we have 8 separate divisions that we work in, or markets that we work in. This goes anywhere from, think of like a celebrity's home theater. We also deal in commercial settings with room acoustics. So think about fabric or wooden panels that you'd see on a wall or hanging from the ceiling to help with the overall noise quality or sound quality in a space. We have noise controlled building materials. Now these are products that would help isolate walls and floors and ceilings even, just to stop noise from traveling from one space into another space. We also have vibration isolation products for mechanical equipment, seismic and wind restraint products. And then we also get into industrial, which basically is our in-plant noise control. This is for manufacturing equipment, loud manufacturing equipment, bringing the noise levels down to typically within OSHA standards. Now, the 2 that I'm going to be talking about today are number 8, our airflow attenuation, and also our environmental market. And essentially what these are is any sort of airborne noise. So any sort of noise that travels through the air generated by a piece of HVAC equipment, and that noise either travels into a space or through the outdoors. So that brings me to my first slide here. And basically what I'm going to be talking about today, I'm going to be giving you a kind of a brief overview right now. We'll talk about a little bit of the science. It's going to be a very general overview. Look at a couple of the products that we use and the application of those products. And then I've saved about 15 minutes at the end for questions, should anyone have anything, or want a little bit more information in depth on some of the topics I've talked about today. So when we talk about indoor noise control, this is typically going to be noise that's traveling either through the supply or the return duct, typically from an air handling unit, rooftop unit, makeup air unit, something of that nature. But it can also be for fan coil units, VAV boxes, smaller equipment as well. It's essentially anytime there is a sound path traveling through the air, typically through the ductwork, into an indoor space. When we talk about outdoor or environmental noise control, this is when the sound path and the person receiving the noise is outdoors. So this could be the outdoor air intake or the exhaust air from one of those units, or even the casing radiated noise. So why acoustics? Well, every time I do a presentation like this, I like to tell a little bit of a story. Now, this was several years ago. I was at an AHR conference, and an acoustic consultant told this story about a recent trip where they went to China and were visiting different schools in the area there, and noticed that a lot of the students were wearing winter coats. And this led them to the observation that it doesn't matter how cold or how hot or how humid or whatever it may be in that classroom, if you can't hear what the teacher's saying, the room is essentially useless. And this doesn't only apply to schools. Think about a performance space, even colleges or universities. It even extends so far as think about being in a hospital room where your comfort is very important. You wouldn't want to have excess noise in those situations. It also extends to the outdoors. So as everyone here is probably very aware, cities are becoming a lot closer together. We have a lot more residential areas that are very close or even right next to an industrial area. The industrial building has been generating noise for decades, and all of a sudden there's a subdivision next door and there's immediately a noise problem. These are typically the kinds of circumstances that we are trying to mitigate with our environmental or outdoor noise products. And lastly, the reason this is important is we want to make sure that any sort of noise control product that we put onto a system is selected properly. They will have an impact on how the product functions, and we want to make sure that the HVAC system is designed in order to accommodate the noise control measures, and that's not going to have an overall impact on the performance of the equipment and the system. So HVAC system noise. Noise in itself is essentially any unwanted sound. Sound itself is energy, and it travels as a wave, either through a fluid or a solid. And so essentially what that means is sound is the energy, but noise is very subjective. What could be loud to one person isn't loud to another. What sound levels are acceptable in one location aren't acceptable in another location. So noise is that, or sound is that energy. Noise is essentially our interpretation of that energy. So when that sound energy is transmitted through a solid, and in the purpose of looking at a building, that's going to be your building partitions. That's going to be when the vibration travels through the floors and the walls. And then when it travels through a fluid, this is going to be the air. So when the air is traveling through the ductwork, when the air is being exhausted, or the outdoor intake, the sound traveling through those paths as well. What's important to remember here is that in any of these scenarios, whenever we talk about noise or sound, we're always going to talk about three separate aspects. We have the sound source, we have the sound path, and then we have the receiver. So the image on the right here, this is a typical school layout. The yellow box is a mechanical room. It has several pieces of mechanical equipment in it. The blue lines leading out of that yellow room are the duct paths. That's the path that the sound is traveling from that unit into the different rooms. The receivers are going to be the people within those rooms that are experiencing the noise that has traveled through that duct. So let's talk about HVAC system noise. Let's look at the source here. So airborne noise is generated either by a vibrating surface or a turbulent fluid stream. And in the case of HVAC noise control, it's essentially going to be when you have a fan. That fan is going to disturb those air particles, and it's going to create concentrations of air particles below and above atmospheric pressure. And essentially what that is the image on the left there. We have a lot of air particles that are condensed, and then they expand and condense and expand. And that's the sound wave. That's how the sound travels through the air. That's how it propagates itself. Typically, we express those concentrations of air in that wave that you see right below it. Now, the rate at which this energy, or the amount of energy that's being released by the sound source, is something we call the sound power level. This is the amount of sound energy that a sound source emits. I like to compare the sound power level to, having a heater plugged into a room. So the heater's plugged in, and it's going to be generating a certain amount of heat. It doesn't matter where you're standing relative to that heater. It doesn't matter how much of that heat you're experiencing. It's always going to be letting off the same amount of heat energy. Same thing with noise and a fan. So let's look at some of the characteristics of that sound wave. The first thing that we look at is either the frequency or the pitch. This is how often those concentrations of air particles happen. The closer they are together, the higher the pitch, the further away they are from each other, the lower the pitch, or the lower the frequency. And so when we work in HVAC noise control, very typically, we're going to be working in 8 different frequencies, 8 different pitches, or sometimes we call these octave bands as well. So this is going to be 63 hertz, 125 hertz, 250, 500, 1000, 2000, 4000, and 8000 hertz. So generally, when we're talking about the sound power levels of a piece of HVAC equipment, we have that sound energy at 8 different frequencies. We also want to know that wavelength. So again, the distance between those concentrations of air particles. And the reason for this being is because a wavelength for a low frequency noise is much bigger than the frequency for the wavelength for a high frequency noise, which means we typically have to adjust the type of noise control product we have to use to attenuate those sounds. Let's move on and take a look at the path here. So on the left, we have an indoor noise path. So like I've already explained, we have a piece of equipment. This one's inside a mechanical room. We have the air traveling from the fan inside the unit through the ductwork to the receiver that's sitting in the room. Same thing can be said for the return path. That same sound is going to be traveling through the return ductwork into the room where the person is sitting. Now, the reason that path becomes important here is because as that noise travels through the ductwork, it's going to experience elbows. It travels through long runs of duct. There's transitions, there's expansion and contraction and expansion that happens of the air itself as it's traveling. And all these things tend to naturally attenuate or naturally absorb some of the noise that's in the airstream. So generally what the receiver is hearing in the space is going to be a little bit less than what's actually being expressed by the fan itself. So when we're looking at an overall, trying to analyze one of these systems, we first consider how loud is the sound source, and then we deduct any sort of natural attenuation that would happen in the duct path as it travels to the receiver. Now, on an outdoor noise path, on an outdoor noise path, the sound propagates a little bit differently. There's nothing to obstruct it typically, unless there's a wall or something close by. But the sound will typically radiate in a spherical way. So it travels in a sphere outwards from where the noise is being emitted. So as you move further and further away from where that sound source is, you're going to be hearing less and less of that noise. What's also going to affect it is at what angle are you relative to that sound source. So if you look at this exhaust fan stack I have on the image on the right here, you can likely see that if you were standing right at the very end of that exhaust stack, you're going to be experiencing a lot more noise than if you're standing on the ground right next to the building. So these are the things within the path that we're going to be considering when looking at outdoor or environmental noise problem. So lastly, we have the receiver. Now, comparing this to sound power, you have a heater in a room that's emitting amount of energy. This is where your location becomes important. How close you are to that heater is going to affect how much of that heat you're actually going to feel. Sound pressure is how we actually experience the noise. It's the force that's imparted on our eardrums by the sound wave in the air. So for in an indoor space, this is going to be affected by how absorptive the walls are in the space, how many diffusers are in the room, or how many registers are in the room. What are the reflective surfaces like? Those are the kinds of things that we have to consider when we talk about the receiver and how they're going to interpret the noise that's being transferred there by the sound source. When we look at the outdoor sound levels or the outdoor sound analysis, we're going to look at things like, is there a wall close by that the noise could be reflective off of? Are there trees or something else in the way that's causing an obstruction? How far away are we from the sound source? What angle are we to that sound source? That's how we determine what the sound pressure is. Now, there's a way to categorize these and specify levels. So for indoor noise, we typically use something called an NC or a noise criteria level. Now, if you look at the chart on the right, excuse me, that's a chart issued by ASHRAE in the ASHRAE handbook. And these are some general guidelines you can use to determine what a typical NC level would be. So for an example, a classroom would be NC 30. A corridor can be a little bit louder, so it can be NC 40. And what an NC 30 or what an NC 40 or 50 means, it basically dictates the highest amount of sound pressure at each frequency that is deemed acceptable. So the chart at the bottom here, you can see the maximum sound pressure levels at each frequency in order for the room to meet that noise criteria level. So when you're looking at the actual sound pressure levels in a space, we want to make sure that the measured levels are the same or lower than the target NC level for that room. Outdoors, we'll use something called an A-weighted response, or DBA. This might be something that you've heard before, a DBA level. And essentially what we do with the DBA level is we look at the raw sound power data for a piece of equipment, or we look at the raw sound power data where the receiver is, or at a property line in an outdoor scenario. We convert this to a DBA number by de-emphasizing the lower frequencies. Just as people, we don't hear low frequencies all that well. We're much better at picking up noises in the mid to higher frequencies. So we really de-emphasize those lower frequencies to give us a better idea of how we're actually going to experience the noise from that piece of equipment. So we have a sample calculation at the bottom here. The sound power level numbers, that's the first row. That's typical for a piece of equipment. That's the sound energy at each frequency from the unit. We're filtering those. Those are a standard set of numbers. And then we have our A-weighted numbers at the bottom. And without going into too much detail here, those are all added up logarithmically to get us one final DBA number, which is 86. So now we'll take a look at a couple of the products that we use to mitigate these sounds. So if we're looking at some sort of ducted air path, so this would be your supply, your return, your exhaust or outdoor air path, we're typically going to use something called a silencer. You might hear this called an attenuator or a sound trap. And it's designed, it's essentially a sheet metal that's designed to replace a piece of duct that have baffles in the interior to absorb some of that noise. So the image top right there, you can see the hatch sections are typically where the silencers are installed, generally closer to the unit to help mitigate that noise before it gets into an occupied space. We have a couple different configurations of these, so they can be rectangular or elbow shaped. We have circular ones to match circular ducts, and we can make custom sizes as well. You can see some examples of completed product on the bottom right-hand side there. And so those rounded sections just in the middle of the silencer here, that is a rounded sheet metal nose. We have some perforated sheet metal here, and then in between the outside casing and that perforated sheet metal, that's where we have what we call an acoustic media. So we typically will use a fiberglass, but we have a couple other options as well. And that fiberglass in there is going to absorb any excess noise in the system. Next, we have our noise block acoustic panels. This is a tongue and groove panel. Typically, it's 2 or 4 inches thick. And we will use these to make acoustic plenums. So you'll see these when you have a series of exhaust or outdoor air intakes on a building, typically in a mechanical room. Sometimes you'll see supply and return plenums as well. We will use them to create a barrier wall. So you can see an image in the middle here where we have a chiller on one side, and we've made a barrier out of these panels to block the noise and to mitigate the outdoor sound path. The panel is generally constructed has a perforated sheet metal on one side. That's going to be the side that faces the equipment. There's a fiberglass on the inside, so that's going to absorb a lot of the noise that's being emitted and prevent any sort of reflections from happening. And then we have a solid sheet metal on the outside. And then these have a painted finish and can look really nice once they're installed. So we'll use them for the plenums, like I said, for barrier walls. And we also do enclosures for these as well. And I'll show you a couple examples at the end. Next, we have our Kmp Acoustic Panels. These ones are very similar to the noise block panel, except for they only have the perforated side. They're meant to attach to an existing structure, and they offer just noise absorption in this case. So the example that you're seeing on this slide, we have an equipment yard, cinder block walls, and the issue here being that the noise was just reflecting off the walls like crazy, got really loud in there. So what we did is we lined the entire equipment yard with these Kmp panels. They're fabricated from perforated sheet metal with a fiberglass behind them, and that allows for a lot of the absorption of the noise. And then lastly, we have our acoustic louvers. These are to control noise anytime the noise is traveling through some sort of building partition. So you can see them installed in a brick wall, and actually just in a moment, I'm going to give you a little bit of case study on that particular product or that project. And then we also include them when we're doing a noise enclosure. So the picture on the bottom there, that's actually an enclosure around a chiller. We're going to do a case study on that one as well. So I've used the panels to make an enclosure and then included the acoustic louvers to allow for airflow to flow in and out of the enclosure to allow the equipment to breathe and function properly, but to also to mitigate that sound that's being generated by the equipment. So there's not a noise problem as the air flows in and out. So let's look at the first example. Now this is very typical. This was a hospital that had a new central utility plant built right across the street. And we were finding that as people were entering and leaving the hospital, the noise level was quite loud. Actually measured at the central utility plant, it's about 111 dBA. And to give you some context, typical noise bylaws are around 50 to 60 dBA at a property line. So this was quite excessive and excess noise in this case. So what we've done is when this building was initially designed, these were typical architectural type louvers that were installed to allow airflow into and out of the building. We had replaced those with 24-inch thick acoustic louvers. Now in this case, you can see a bit of a profile of the blade that we used here. It's a chevron shape. That just allows for extra noise control and also allows for blocked line of sight. So someone who's walking by wouldn't be able to peek between the blades and see what's happening in that building. So it adds for a little bit of extra security. Here's a second example. So this was a chiller at a school. Again, a lot of these applications end up being retrofit. The majority of the projects we do aren't, the noise control is not planned ahead of time, ends up being a retrofit solution because the noise was not taken into account early on. So this is a chiller. The picture that you're seeing here was basically taken from the sidewalk. In this case, we did provide the structural steel and the structural engineering for those posts. So this is with the posts installed. Here you can see on the outside, we've used our noise block panel to make an enclosure around it. We've included our acoustic louvers as a bit of a skirt there to allow for the airflow. And then we have an access door to make sure that someone can go in and do regular maintenance on the equipment. The picture on the right there, you can see on top, we've used our same noise block panels, but essentially made a pergola roof. So for the same reason of the louvers, we are just allowing for proper airflow, but then trying to mitigate that noise that's being emitted upwards from the chiller. So I'd like to thank you very much for your time today. I'm going to turn it back over to Lisa here so she can pull her new slide up. And I welcome any questions that you may have. Thank you again. Just have to figure out how to stop sharing here. There we go.
Thank you so much, Kristen. That was awesome. I definitely learned a few things, and you never realize like how much goes into something like that, So thank you so much for that. And Lisa, thank you for sharing about AMCA. And once again, we're so grateful for that partnership. And so let's open it up for questions or discussions. Any application questions, or how else can you use this knowledge for your business? Let's go ahead and chat about that. Lisa, nobody can hear you for some reason.
Oh, that's okay. It's this lovely self-mute button I have on my headset that I have a very bad habit of hitting randomly. And my coworkers make fun of me for it all the time. So I have put on screen. Hopefully you can, no, you can't see that quite yet. Erica and I and Kristen would all really appreciate if people would go ahead and take a very short survey about today's program so that for future joint programs, we can be sure that we're offering things that are of interest and appeal to the audience. Obviously, you can scan the QR code with your cell phone camera. There's also a regular email link there, and I can make sure that we send that link to you all via a separate thank you email in case you don't want to mess around with the QR code, but I'll leave that up for now. Excuse me. And definitely if anybody has any questions, Erica, could you moderate that if they come in? And they can be questions about Kristen's information or about AMCA in general. Or anything else that the audience would like to chat about today.
I don't have questions, but I'm super impressed. And we do a little light commercial in my company, but now I look at this, it's kind of opened up a new world for me. So when I go up on a rooftop and I have a greater understanding of some of the things, because noise complaints, that's ongoing. It's constantly, whether it's residential or commercial. So this was very informative. Thank you, ladies.
Thank you, Lori. That's a great comment.
Yeah, thank you, Lori. And just to add too, I mean, I didn't, the residential work that we do isn't usually the showpieces that we have the images of, but we've done residential small generators or pool pumps even. Small air conditioning units, that sort of stuff comes up all the time because they're creating noise problems for their neighbors. So it doesn't just stop when you leave the commercial building. They happen all over the place.
Yeah, and we're based out of like Seattle area. So Seattle has huge noise restrictions. There are only certain units we can use for residential application, within lot lines and things like that. It's like crazy. If we're not at so many decibels, it's like we have to strip out the unit and put in a new one. And I know our distributor, Gensco, has brought in special units specifically because of, some of the codes and laws in Seattle. So again, nice job, ladies. Thank you.
Thank you. And while other people might be thinking of questions or submitting questions, Erica and I will remind you, the recording and the PDF version of both of these presentations will be posted. Erica will take care of that on the Women in HVACR side. She did put in the chat that the recording will be on their YouTube channel. And then on the AMCA website, we will also post it as well. So if anybody missed anything or wants to go back as a point of reference, we of course will make that available to you.
Yeah, hi, it's Deborah.
Hi, Deborah.
I want to thank you, ladies, for this presentation. It was really, it was very, very helpful. I mean, we don't do this big commercial stuff, but it really helped answer some of the questions or some of the things that have happened. We've got a fair amount of rebuilding of the older buildings in downtown Tulsa with the high ceilings, and they have all the exposed ductwork. And you'll be in a room and you have to turn off the system in order to hear people who are trying to do a presentation. And it shows that they need to have some dampening devices. And it's probably could be potentially an easier solution than having everybody consistently uncomfortable in the room, or having to open the door up because you just don't have enough airflow because you've had to turn things off. And we recently had a customer who wanted us to put her furnace in her attic because, again, she had an older home that had been renovated. So the furnace was in the closet in her house, and wanted all this ductwork put into her attic. And essentially, it was where her fan needed to be readjusted because it was set too high relative to the amount of ductwork that she had. And other contractors were just about ready to put it up in the attic because of that appeared to be the solution. And actually, my contractor just changed the fan and revved it down, and the miracle happened. She could actually go to sleep. She had trouble sleeping during the daytime or when her system was going. So no, this has been really interesting. Especially if you're a nerd, you like this kind of stuff. I like this.
Well, thank you very much.
I know too, Kristen, when you said that story about, that classroom in China, I was in China as well. I was teaching English, and my school had the same kind of thing where we were always wearing winter coats. We were always wearing jackets and sweats on top of our pants. Like, it was always just super cold. And so, this kind of information is just so valuable. And, I know that there's a lot of places, in the United States or Canada or Middle East or all these places that AMCA even has that same kind of issue, not just in schools, but everywhere. And so this is one piece to the whole puzzle, right? Of making things comfortable. And that's what HVAC is for. It's comfortability. Is that even a word?
We need this in our church because people bring blankets in there because it gets so cold. And you can't hear. It's like you have to choose between, are we going to hear or are we going to be comfortable?
Exactly. I mean, I say that only just because noise tends to be something that people just don't think about, right? I would say, especially when we look at, whether it's in-plant noise for industrial or outdoor noise for like environmental, it's the last thing on people's mind. And we're being called in after the fact, right? Your church is too cold, but you can't keep the HVAC unit on, or, I turned my unit on for the first time and now my neighbor's complaining, right? So, I try and tell those stories just to give people the idea to, okay, well, maybe I can start looking at these things prior to putting the equipment in. But, we hear that same sort of thing all the time.
Yeah.
Well, Kristen, I was thinking of that too. When it comes to troubleshooting, it's always easier, obviously, in life to plan ahead than have to backpedal and course correct and redirect. From your perspective, how do you plan in advance for something so it doesn't become a problem?
Oh, thank you, Lisa. That's a great question. So there's a couple things you can do to plan in advance. If you have the budget for it, I always like to recommend getting in touch with an acoustic consultant to have them advise. That's a separate company altogether that would look at your system and take measurements and go into a really detailed scope of it. That's obviously not very cheap and very rarely in the budget for anyone to do. But that being said, when there is a more limited budget, I like to say, let's take a look at your unit. Let's take a look at where you plan to install it. Our company has decades of experience. We can take a look at the situation that you have there and typically how loud the unit is and start recommending solutions at that point. We can do some basic calculations on our end to look at what the situation might be and propose some solutions that could be implemented prior to everything being up and running.
And do you find in your professional experience that happens on a consistent basis or not really so much?
Not very much. We're starting to see more and more of it as these problems become more prevalent. We do see it more often, but definitely we still do far more retrofit than we do new build construction. Wow. For sure.
Wow. Interesting.
Oh, sorry. Excuse me.
No, Shelley, please go ahead.
I was just going to say, while you're talking, I'm trying to just find, like, I'm thinking about the people that I work directly with and some of their sound issues that they have. And I just loved just the idea of getting that acoustic help in call centers and things like that, because so many times you call in, and this is more for, you know, voice to voice type of sound issues that they have. But I'm just reflecting back on the screenshot that you showed earlier about all the different ways to help absorb that sound. And I just think there's such a great need for that too. Maybe we can sometime talk about utilizing some of those other tools to eliminate extra sound in the office place too, because you want to be able to have that personalized experience when you call into an office and not feel like you're talking with 30 other people. So I think this was kind of just fun for me to just kind of get a glimpse at that side of it as well.
Absolutely. Now that's something that that Kinetics does as well. Now that's not my area of expertise specifically, but you know, if you're interested, I can definitely get someone else from the company to give you some more information on that.
Awesome. Thanks, Kristen.
Yeah, no problem.
Well, and it makes sense when you think about, you know, all right, the work from home environment has really changed the office landscape. But the housing market, you know, when you're talking about high rises and whether it's apartments, condos, townhouses, et cetera. I live in a townhouse complex. It's 4 joined units in one structure. If my neighbors are arguing, I can hear them. When the son plays his trumpet or whatever instrument he's trying to learn in the garage, I can hear it. You know, so I wish somebody had done some acoustical planning in this building, and they're not going to do retrofitting, but yeah, you know, it's such a common problem that it's surprising it's such a common problem.
Mm-hmm. Definitely. Interesting.
I see a question in the chat here. Interested in learning more about acoustics, and I currently work in the silencers louvers. Is there a course I could take to improve my knowledge in the field? In terms of a course, I don't know of any in particular that in regards to selecting and designing silencers and louvers. Everything I've learned is from my colleagues who have far more experience than I do. Unfortunately, I don't know of a particular course.
Kristen, what kind of education resources do you all have through Kinetics?
Oh, we don't have any sort of formal education. I do believe that they would support you in terms of gaining more experience if that's what was necessary. But I have colleagues that have been in the business for pretty much their entire careers, and they've been the ones who I've relied on, and they've been the ones who have mentored me to have the knowledge that I have now.
And I'm even the beauty of technology when it works. I'm looking at your website. Shame on me for not having looked at your education offerings beforehand, but I see that you have a number of technical presentations and live CEU courses on designing for room acoustics, noise control, understanding and reducing air system noise, obviously. So I'll put a shameless plug in for both of us. Kineticsnoise.com is where you can find information from Kristen's organization, and maybe some of that would fit the need that this person is mentioning. The other shameless plug is amca.org. On our education page, if you are not seeking professional development hour credits and you just want to explore the variety of webinars that we've done previously, we've done a number on sound, a number on noise, balance and vibration, all kinds of stuff related to sound, acoustics, etc. You can access those webinar recordings for free at amca.org on the education page. And we've got 2.5 years of webinar recordings. Yeah, so those are my 2 shameless plugs for educational offerings for free in most cases.
Thank you so much, Lisa. I almost forgot about all the webinars we've done over the last 2 years. One of the great things that came from working remotely. So thank you very much for reminding me and putting that plug out there for us.
Yeah, it goes quickly. Time goes quickly. It all blends together. But education, is a goal of, I think, all of us in the industry, not just AMCA and Women in HVACR. I know they have fabulous stuff on their website as well. But what good are you if you're in the industry and you're not promoting continuing education, professional development, sharing the knowledge and the resources? I know that at AMCA, we don't believe in siloing our knowledge. It just does us no benefit, because then we can't grow our membership and we can't ensure that all of you, in conjunction with us, are doing the best work you can be doing. So that's my kumbaya moment.
I love it. And I know you've been getting some comments in the chat just saying thank you so much for today. And we appreciate your time. And yes, Women in HVACR is big on education too. That's one of our mission, part of our mission. And so I know what you're saying there, Lisa, is so true. It's very important.
Yeah. And if there are other topics that people are interested, if any of you have topics you're interested in learning more about, on that survey, there is a text box that says, what other topics would you be interested in? And I mean, believe it or not, we really do read the surveys. We really do look at the comments. That's what I think helps drive our initiatives, so that we're appealing and providing what the audience wants.
Absolutely. Thank you so much, Lisa. And I know we're almost out of time for today. So just want to thank everyone again. Let you know, next week, Friday, our webinar is going to be presented by another new partner called Community Connections. So they are also a nonprofit, and they're going to be talking about how to empower youth and breaking cycles of generational poverty. One of their initiatives is getting kids into schools and off the streets and into the trades. And so they're going to be sharing with us about their process and what they're doing to help change and bring more people into the trades, especially women. So we will see everybody next Friday. And thank you again, Lisa and Kristen. Everyone have an amazing weekend. And we'll see you then.
All right. Thanks, everybody.
Thank you very much.
Bye.
Bye-bye.
Take care.
Bye.